Okay, mainly we are going to be dealing with probability distributions with discrete random variables. Okay, but we're going to talk about the two different variables, discrete and continuous. We're going to just construct tables and graphs, find mean, variance, and standard deviation of a probability distribution, and expected value. Easy breezy. So here we go. So discrete versus continuous. Discrete variables are separated. You can count them. Continuous are things like weights, where it's on a scale and it can be in between numbers type of thing. Volumes, that type of thing, where it's not a separate number. If I was looking at a number line, it could be any number in between these two. On this case, if I was looking at a number line, it would be separate dots. Okay, you can count them. Right? So discrete versus continuous. And like I said, mainly what we're going to be doing today is discrete. Okay, so determine whether each is discrete or continuous. Let X represent the numbers of Fortune 500 companies that lost money in the previous year. Discrete or continuous? Discrete, you can count. You can physically say 1, 2, 3, 4, I can count them. The X represents the volume of gasoline in a 21-gallon tank. Continuous, because there's not going to be full gallons. You know what I mean? It's not going to be I have 1 gallon, or I have 2 gallons, or I have 3 gallons. It's going to be 2.637 or whatever. Okay? All right. Discrete probability distributions. And again, some of this is common sense. If you're looking at the complete distribution, all of the probabilities must equal 1. The probability of each value in the discrete distribution has to be between 1 and 0 inclusively. Okay, so when you're looking at a distribution, all the probabilities should add up to 1. That means they're all included. And if you're looking at the probabilities, none of them can be negative or greater than 1. Okay, it has to be between 0 and 1 inclusively. Bless you, bless you. I'm sneezing all over the place. So, if you look at this probability distribution, all of your possible outcomes are listed. So, they ask the sample of families how many vehicles each owns. Okay, so nobody owned more than 3 vehicles. All right, so 0.4% owned no vehicles, 43.5% owned 1, and so on. If you were to add these probabilities up, they're going to equal 1.000. There are no negative probabilities. There's no probabilities over 1. They add up to 1, and you don't have negatives or something higher than 1. Then we're going to be able to put it in a histogram with the probability on the side, or you can call it relative frequency, the same thing. Okay? So again, we're going to be able to do this, right? Okay. So let's look at a couple. The industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. 3 indicates neither. Blah, 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 blah. Graph the distribution using the histogram. Find the results, all that fun stuff. So, how many people got a 1? 24 out of how many total? 150. So I'm going to divide 24 by 150. I get 0.16. And then 2 is 33 out of 150. Those who got a 3 is 42 out of 150. So this is the binomial distribution that we're creating here. And I included every single result and their probabilities. If I added the probabilities, which you should always do to make sure you put them all in there, you get a 1. So this is a complete probability distribution. So our histogram, what's our vertical axis going to be? What should you make it up to? Maybe 0.3. Okay, you don't have to go all the way up to 1 because I'm not going to. And then the horizontal axis is going to be 1, 2, 3, 4, 5. Okay, so it should look like this, maybe. Easy enough. Little total, probability, score. Little bars connected. All right, everyone can do that. It's not really that hard. Okay. Tell me, is this a probability distribution? It looks good. It says days of rain and the probability of such 0, 1, 2, or 3. So what do we have to do to tell if it's a probability distribution? We'll fall there. When I add them all up, the sum of the probabilities equals 1. Are any of the probabilities negative? Or greater than 1? No, so it is a probability distribution. Easy enough? You have to show. That's how you would explain. All right. Is this a probability distribution? Same thing. The sum of probabilities here are what? 1.07. So this is a no. It's not a probability distribution. What about this guy here? If I add these up, no? We're sure? Why? It's kind of negative, right? Okay. P of 4 equals negative. So this is a no. Okay? Easy enough. The mean of a discrete probability distribution is the sum of each x times its probability. So you take each random variable times the probability and add them up. That is the mean. And put a little asterisk. It's also considered the expected value, which is at the end of the lesson. For some reason, they separate it. The expected value is also the mean of the distribution. So it's the sum of every x times the probability of that x. Okay? So, here we go. Don't make it hard. This is how we do it. X is 1 times 0.16 plus 2 times 0.22 plus. Now, normally with average, you end up dividing by a whole bunch of stuff. Do we have to divide in this case? No, because these probabilities have already been divided by the total, right? So they've already got that division in there, okay? So we're just going to do it. Plus 2 times 0.22. Let me ask you this before we actually put our calculators to use. Where should this be close to? Look at the numbers and their probabilities. Where's the bigger probabilities happening? Around 3, because these are kind of almost the same. Does that make sense? There's a little bit more below 3 than above 3, but 3 is the mean, or not the mean, the mode. So when I put this in my calculator, I got 2.94, so it's right below 3. Okay? And you can look at that and see, just from the table. 0.28's got the most of them. There's about the same on either side, but a little bit more on the lower side. Okay? Does that make sense? You're literally taking top times probability plus all over. All right. Moving on. Mean, variance, and standard deviation. So there's the formulas. But I want to talk about one. So the mean we just talked about. The variance. They tell you to take each x, subtract the mean, square it, and then multiply it by the probability. Now, I'm going to show you just a little bit of algebra. Okay, the standard deviation is always the square root of the variance. So we're going to use that shortcut because it's so much easier. All right, here we go. Let's find the variance and standard deviation. So the variance formula is x squared times the probability. You're going to add all these up. 2 squared is, well, I'm just going to write it with the formula. And then we have to take that and subtract the mean squared. So I guess we should have found the mean first. Point what? We already had that from the other example, right? Minus 2.97? Okay. So use calculators. I mean, I personally would square things in my head instead of and remember, this is the variance. And then to find the standard deviation, you are simply going to take the square root of that. Okay? So really quite easy when you do the shortcut. If you don't do the shortcut, it just gets ugly. All right. Here we go. Expected value. It's just the mean. It's just the mean. But it's a little different because they want you to set up an expected value table. So if it says at a raffle, you have 1,500 tickets are sold, $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. Find the expected value and interpret its meaning. Well, how many different outcomes do you have here? We're going to put money 1. Okay? How many different outcomes do you have? You have 4 prizes, but you have 5 outcomes, right? Because you're going to lose. Okay. So if I lose, how much do I win? Nope. Negative $2. You pay $2 to lose, right? So you've lost. Your winnings is actually negative 2. If I win 500, how much do I actually win? 250 would be 248, right? You're going to take away your $2 investment. Okay, so we're selling 1,500 tickets here. So I have 1 ticket that is going to win the big bucks. I have 1 ticket that's going to win a second prize, 1 ticket that's going to win third, 1 ticket that's going to win the 4th prize, and how many tickets are going to lose? Right? There's a lot of tickets going to lose. So what is the expected value of this distribution? What is the mean? So you're going to do negative 2 times plus 498 times, right, the probability? Would it be easier just to multiply by the numerator and then do a big old division of 1,500? So negative 2 times 1496 plus 498 times 1 plus 248 times 1 plus 148 times 1 plus 73 times 1 divided by 1,500. That's the expected payout. What does that mean? The people that are running the raffle are making $1.35 for every ticket sold. So they're going to make, after paying out their prizes, $2,025. Does that make sense? This is the expected outcome. You're going to lose $1.35. So they're going to make $1.35. Does that make sense? So you can think of it two different ways. How much you're losing per ticket or how much they're making. Okay? And then they can multiply by how many. Easy enough? Okay. That's completely wrong. All right.